I'm very happy to see all of you, and I want to welcome you all on e-waste and public health pollution workshop organized by Society of Environmental Geochemistry and Health 2021. This was the idea that was generated by the president of the society, Professor Michael, and he suggested that we should have activity, sea activity from the Asia. And when I approached different members of the from the Asia, then I found that almost all the members are working in the electronic waste pollution. So I generated and I developed the idea of the workshop and title as electronic waste pollution and public health. So as you know that Asia is highly urbanized, and there's a lot of industries in Asia. There is so many manufacturing of the electronic products and goods in Asia, and that these are transported within the Asia and other countries of the world. So in one side, they are very beneficial, and in another side, they pose some toxic effects to the environment, to the public health. The workshop on this title should be would be very timely and will provide important knowledge to the audience. So I we have five different talks on different topics regarding human exposure and effects of pollutants on the immune systems. We have some e-waste recycling and its pollution information from India, PCB's toxicity to the human cells, and the application of the some statistical analysis in the modeling of the pollutions. In the introductory and welcome speech, I welcome Professor Dr. Taichan An. He is the director of Institute of Environmental Health and Pollution Research. Professor Taichan received his PhD in environmental sciences from Sun Yat-sen University, China in 2002. He is currently a full professor in School of Environmental Sciences and Engineering and the director of Environmental Health and Pollution Control, Guangdong University of Technology. He has published over 100 patents and published over 480 referred research papers. He was selected as one of the most cited Chinese author in the field of environmental science by Elsevier. Professor Tian, I welcome you to deliver a welcome and introductory speech.
Okay, thank you. Thank you, Safar. Yes, so it's okay?
Yeah. Yes, it is okay, Professor Tian.
Okay. Yeah. Hello, everyone. So it's very happy to have this conference, especially we have such a conference, right? So actually, we're supposed to have the one bigger SEGH conference in 2020, last year in the Nanjing. So I supposed to host the 37 SEGH conference in Nanjing and host with Nanjing University and Guangdong University of Technology. But due to the virus, we cannot come together and discussion and have some meeting together. So today we finally get the
waste pollution and public health workshop
conference in the Asia
2 p.m. Beijing.
Right? But actually today we just only in Asia gathered together, have some conference. So we have some common interest about the e-waste and the e-waste pollution and the environmental health like this. So today we have the five speakers and come from 5 countries, right? Yeah. So all is focused on the e-waste and the pollution and public health. So that's a really good opportunity to us to do something, speech here and give some representation and give our new result out and the discussion with each other. Maybe literally we can do something together with the e-waste and the pollution, and of course environmental health. Yeah, so maybe this today we just the beginning of the as the e-waste and the health. Yeah, so really nice to see today we have the good conference and the webmails together here. And maybe later we have some another conference for all SEGH. And we have nice to know some people because I sent to SEGH China community. Maybe more and more students and teachers will come and join us of the conference later. Yeah, because I just sent the news to about 1:30. Yeah, so maybe it's good to let's more and more people join our conference today and talking today. Okay, so it's really great to me to have this conference together and give some good and new results for our research. Okay, thank you very much. Welcome to everybody to come in this conference. Cheers. Thank you.
Thank you. Thank you. Thank you very much, Professor Taichan, for your welcome and introductory address. And you have shared a valuable experience regarding your time in sea activities in the past. There is a one famous quote by Wendell Berry: "The earth is what we all have in common." So the first topic of the conference is that of the workshop is human exposure risk of chlorinated and brominated pause from e-waste dismantling process. And Professor Taichung will deliver his talk. Professor Taichung, please feel free to deliver your talk.
Okay, can you permit me screen share? So we need your screen share. Yeah.
Yes, you can. I think multiple.
So
Yes.
let's say that you should permit.
Okay. Okay. Can you? Yes, I have permitted you.
Okay. Let's come in. Yeah. Okay. Can you check? It's
yes,
okay,
it is
right?
Yes, it is fine. Thank you.
Okay. Okay. Thank you. So thank you. So today my topic is human exposure risk of the chloride and the bromide. That's mean halogenic PAH from e-waste dismantling processing. So we will check something e-waste processing pollutions. Let's see, this is outline for my presentation. Firstly, let's see the introduction. So, you know, is recently as the world and domestic e-waste become more and more. And the problems is the amount of the domestic e-waste Chinese is well reached 28 million tons in 2030. So when the environmental problems caused by the e-waste in the world and has attracted the attention of the government and many research. Let me see, as today we see 5 topic is all the focus on the e-waste. You know, we come from the 5 country and the 5 speaker, all of the focus on the e-waste problems. So that means really e-waste problems is some problems for the peoples. So when you're doing cycle protection, is maybe some metal and non-metal material as reused, and also can be increased some environmental and get some monies from the peoples. But we still have some environmental beneficiaries. Balance the economical environment. So we don't need use some new miners. So we can recycle some materials can be replaced as one. Also, that's actually very important. The carbon nutrition, that is also very important for to recycles. So when we know when the e-waste recycling process, we have the pollutant, some many pollutants, for example, some metals and in the air, and also some toxic organic pollutants coming here. So today we just focus on the chloride and bromide pH, not the VOC, not PBDE, and not PFOS, and not other pollutants. So that's because the e-waste debris, the workshop dust, and the surrounding soil and the vegetable and the atmosphere as this kind of pH, as halogen pH, we are just focused on. Although we do many working e-waste pollution from the e-waste, yeah. So let's see some research on halogen pH. You can see halogen pH, for example, chloride and bromide pH has carcinogenic and tetragenic and mutagenic toxin like dioxin, Now that means why? Because the many metal smelting and waste in scenario and also different environmental distribution characteristic is very important. And finally, unclear formation not to understand. So that's really we need to do some research for that works. So that means my introduction goals is to establish analytical method to actually quantify the different homologies of the halogen pH. And the second is to determine the pollution profile of the halogen pH in the indoor dust and also air from e-waste demethyling working shop. And finally goal is to estimate the human exposure risk of the halogen pH and clarify the comprehensive occupation exposure in the e-waste recycle industry. So the method, the second is method developed. So we firstly get the research the separation of halogen pH. We select the different columns, use DB5, DB35, and the DB13 MS columns. Finally, we get DB135 MS columns present the best performance for the separation of the 34 halogen pH. That is the 6 meter legend as columns. And we find get the halogen pH in different source models. We check the ice model. We can say ice ionization almost exclusive to the generally only chloride as a 35 and a 37, or bromide as 79 and H1 is the get this for this ionization, but no molecular ice or specific fragment ice could be selected as a precursor ice. So that's it's difficult for us to determine. So we also check the halogen pH in different instrument analysis. We compared GCERMS and the GCNCRMS and the GCERMS. So we finally get the best selection. The sensitive was obtained for the halogen pH by GCMS and MS in EI models, EI models. And this method can be used for the routine determination of the halogen pH in the samples from various environmental, also from dust and the air like that. So can get a good result recovery. And let's take the GCEC MS analysis for halogen pH. We can find optimize the qualitative and the qualitative of ice pairs, and we find the parameter of the analysis of the certified halogen pH by GC be successfully established. So you can, if you want get some detail, you can get this method from our published paper. You check the later. And also we can be used the method application. We used for workshop dust sample determination. And here we used a total 15 samples in the 5 sample site as used for dust survey. So we get 5 sample sites. So first way, a e-waste dismantling workshop, real the dismantling workshop. As the RW is the raw material crunching workshop. Yeah. And BW is the second Cooper Blaster funeral workshop. And also we get some office building area, OA. And RA is the resident areas. That means people's living here and get some sense. And some standard reference material 2585 organic contaminated in the host dust as a compare. So we get some halogen pH in dust in the workshop. So we find the get result EW and the IW and the BW site. Something, some people say something, right? Sorry. So we can find the bromide pH is largely the chloride pH. And the concentration of the 1 bromide PRY as was the highest is the species. And the host for halogen pH is the this 3 sites is a lot better than higher than OA office areas and office areas. So that means the waste disposal process is the main factor influences the formation of the HPH, because you can say all of the dismantling site is a larger higher than the office areas. So also we checked the emission profile of HPLC. We can find the low mean chloride pH, for example, 2 chloride PHE or 2 chloride ATN, and the 9 and 10 is 2 chloride PHE was the highest higher ring bromide pH, and that was the dominant the species. And the treatment of the process and the dismantling as the temperature is are quietly different from the various workshop and the dismantling technologies, which will be result of different emission profile of HPH in the dust. That's very important for use the different technology and use the different temperature. Yeah, temperature. We further check the dust ingestion exposure of the halogen pH. We can find for workers, the dismantling workers, so we can get the very higher chloride pH, 7.78 to 20 thick, and the bromide pH only 5 to 50. But for residents, you can see only 3.55 to 30, and the bromide is very much larger, lower than the workers. But although both of the very higher, but still very low than the tolerant yearly intake recommendation by the WHO for dioxin. So we cannot use the use this one, only used for dioxin as compares. That means the human exposures to the bromide its pH adsorbed to the dust in the workshop through the ingestion for the working should be a cause of the concerns. So we need to check about this kind of the bromide pH, maybe is some risk for that. So we also check the workshop air samples to get the halogen pH samples. So see, we also use the 5 typical circuit board dismantling at the recycle workshop. During the dismantling or the notice, compare the dismantling and the not dismantling working model. And also totally 20 samples getting. And you can say, use the different dismantling activity. For example, electronic blower to treat the mobile phone is electronic heater fuel to treat the television, and the electronical heating fuel to treat rotor, and rotate incinerator as to treat the television, and for also to hard disk, and also we use the control areas, the resident area to as control. We're also working on the indoor air, and also some as the from the home as hood. So you can check this here. So details information is kept from the papers. Okay, so we can get in the air halogen pH, and also we find the highest chloride is the bromide pH get the rotation incination as for TV and for some flame retardant. And also we find that the bromide pH is largely for chloride pH. That means we also check the bromide pH is maybe some risk for the consensus. Yeah, and also we check the formation is from the carbon source and the halogen and the various metals, because you will check during checking diplomating, we have many halogen and metals can come together, and they maybe can leading something more halogen pH. For its bromide pH is more sensitive to combustor material and decomposition conditions, for is very important for dismantling temperatures. And also for as the chloride pH, but we not get some no obviously difference for different dismantling result, and because that gets the result. But for bromide pH, we can get the different obviously different pollution levels, get the different. That means that maybe can get the many more bromide pH in hairs. So we also check the congenital profile of the HPH for here in different workshops. Yeah, different workshops. So we check the many workshops. So we can compare the different works, and we finally compare the result. We find that the congenital profile of the chloride pH you can see here, and the bromide pH you can see come here, and completely different from other workshops. That means we can use the maybe fingerprint for source traceability of the bromide chloride pH in the environmental. Maybe you can see come from the dismantling workshop, as although is the chloride bromide is completely different, differently, yeah, a composition. And also we checked the correlation of the HPAC with the parent pH. So you can see as for chloride pH and bromide pH, we can find some different result. And you can see as chloride and bromide pH can be generated by the second halogenation reaction pH. You can see as different as some highly chloride bromide from flame retardant may be also served as a potential precursor to form HPAC, HPH. Yeah, so that's because many bromide chloride flame retardants that maybe get this HPAC. And also we checked the potential human health risk by the inhalation. So you can say use the inhalation and the demo context. Yeah, all okay get the good results. You can see we get the result like the inhalation is largely than demo contact, and we can get the result about the male working is largely risk than the female works, but no significant difference result getting, and just have a little larger than this one for female workers. And also we checked by the result carcinogenic result, and we find the exposure risk is lower than the EPA acceptable range, about larger than because most is -9 as -10 20 12. So generally is acceptable range about the -6 and -4 like that. So that means although they maybe can give some many halogen pH, but they still can be safe as the EPH standards. Okay, so let's come conclusion. GCECMS best method would be preferred for the routine determination for halogen pH in the sample from various environmental, although for the dust and the air like that. And the second is concentration bromide is the higher than that's the chloride pH. And the formation and the emission of the bromide are more sensitive to the combustor material and the decomposition condition like that. So for example, maybe some material contains bromide flame retardant. And the third conclusion is the congenital profile of the specific distribution about WPCB as the result will be served as possible fingerprint and the source appointment for environmental traces of the halogen pH. And still we have some limitation due to the lack of available data for the halogen pH in indoor dust sample, as well as the IEP BPA for calculate TEQ of the halogen pH. Most studies should be working for toxin potential of this kind of pollutants are still required in the future in order to actually estimated the human exposure risk for HPH. The formation mechanism halogen pH in different workshops are still unclear. So further investigation should need to be clarified the specific formation mechanism. There's still very difficult challenges. So finally, we get to the acknowledge. So thanks for National Science Foundation and the Guangdong Processing Department of the Science and Technology for money support. And thanks for your attention. Thanks a lot, Chair.
Thank you very much, Professor Tai Chung, for your important result and regarding pH distribution in different environmental compartments. their risk assessment, and particularly their distribution in air workshop and in the dust media. If someone wants to ask a question, you can please unmute your microphone and you can ask a question to Professor Taicha. Do you have any question?
Yes, I have a question. Can you hear me?
Yes.
Yeah.
Okay. I think it's a very good job. And my question is can you get some human samples, samples
Oh, yeah.
that
So actually, we get some human samples from this area for about 1,000. But still, we have some analytical method for determination this kind of people, this kind of samples. So where is come from here and originally, or where is the for metabolic sample? So this is still very difficult to distinguish as the inside and the outside exposure samples. So we still struggle for get distinguished them each other. So we still not published papers, but we still working on this one. Yeah, thank you.
Yeah, thank you. Thank you.
Thank you. Thank you very much. Any other question from the audience? Okay. Our next talk is about effect of pollutant exposure on immune response to vaccination in children from e-waste recycling area. The talk will be given by Professor Dr. Shahu. She is Professor Dr. Shahu received her medical degree from Guangxi Medical University in 1983 and her PhD from Southern Medical University in 1998. She was a visiting scholar at Göttingen University from 1990 to 1992 and at the MD Anderson Cancer Center and the University of Texas Medical Branch from 2005 to 2006. Currently, she is a professor at Jinan University, China, where she directs the Laboratory of Environmental Medicine and Developmental Toxicology. Her research interests focus on environmental pollution and children health, including the effects of environmental pollutants on the development of children, early life pollutant exposure, and disease susceptibility, and environmental pollution and immunotoxicology. She has presided over 6 research projects, published 13 book chapters, and over 220 scientific research articles. I welcome Professor Shahu to deliver her talk.
Can you see my PPT?
Yeah,
Okay, one.
we can see. Yeah.
Okay. My name is Yaho. I'm from G University. Yeah. My is effect of potent explosions on immune response in vaccinated children. Free in mentors to be used by player many times in history until vaccines be invented. For example, smallpox vaccine invented by a British doctor Edward Jenner in the end of the 18th century for preventing the spread of the smallpox disease. This is the smallpox virus. In the history, in China, in the Qing dynasty, there are 4 emperors were infected with the smallpox, and 2 emperors died of the smallpox at the age of 24 and 19. Yeah, it's very young. In 1980, WHO announced that human beings had constantly eliminated smallpox. Now, only in the laboratory of this virus. Vaccination is the most effective measure to prevent and control infectious diseases. Yeah, now, for example, the virus, yes, so cannot cover everyone with a school in the public. So we need a vaccination too. In China, there are 12 vaccines for children in different vaccines. So immune response refer to be stimulated by antigens, for example, the virus and the bacteria or vaccination, leading to a process of immune cells recognize is the virus, bacteria, or the vaccination. The activated proliferating differentiating to produce antibodies and arouse specific immune effects. The infection of pathogenic microorganisms not only cause serious damage to human body, but also increase the risk of major diseases such as tumor, SEGHLive, example, hepatitis. Hepatitis virus can lead to liver cancer in the late life. HPV can lead to cervical cancer. So many pollutants are immunotoxic. Our question is whether the pollutant explosions interfere with the immune response and produce a process such as antibody titers after vaccination or not. Our research field in Guiyu, Guiyu is a recycled town, e-waste recycled town. Guiyu close Hong Kong, in Central City, in Guangdong Province. Just Taichung already tell us e-waste is increase, is growth in the world. Have the yourself and lab and journals and so this research, technical result of this research is focused on the children from newborns to children. Their children from e-waste recycling, they get some pollutants and together 12 different vaccine is free. They must vaccination before they go to school. Otherwise, they cannot go to school without the vaccination. So we measure the antibody after this vaccine. You can see different 12 different of the vaccination. After vaccination, in kindergarten, we measure the antibody and the hemoglobin of the children. This area, this e-waste recycle area, we can see the PM 2.5 is higher in Guiyu, the green one is Guiyu, is PM2.5 and the PM10 and the other pollutants in Guiyu recycle area is higher than the reference group. And also we can see the heavy metal is the in is high, 150, much higher than the reference group. The metal also Guiyu group is higher than the reference group. Soil robust, we can see in Guiyu also much higher than the reference group. This we have reached in different journals. Our research focus
Professor Shah.
internal exposure. Yeah.
Professor Shah,
Yes.
can you share your presentation slides on the screen? As we are not we cannot see.
You cannot see the
Slides.
Okay.
Thank you very much.
Wonderful. Sometimes internet is not. Our research focus on the internal exposure. For example, we measure the children blood level, and other heavy metals. We can see in the gray group, the dark one, the blood level, much higher than the reference group. Other chemicals, other heavy metals, we can see also some of them also cadmium also higher than the reference group. We can see from 2004 until recent year, the gray group, the blue one, is much higher than the reference group. In the year 2009, there are a decrease in the children's blood level because this year is financial crisis. Global financial crisis. Many workshop, many recycle, even recycled workshop is closed. So they have a decrease. And the recent year, the local children's blood level is also decreased. Also decreased. So this means the central recycle center is work, for the local children's health. And bladder, PBD, pH, PCB, and the PFOS, we can see also in Guiyu group is also higher than the reference group. So in Guiyu, the children have a complex mixture chemicals, pollutant exposure. So we measure the antibodies of the children. As we know, any children in China, they have free vaccine for the hepatitis virus against virus. We see this photo and this fish. The Chinese group. This one group. See, we have lower antibodies levels in the reference group, and this is the level. And the group children have higher level than the reference group. This paper already published in the journal Hazardous Materials. We can see from this finger, even in the reference group, if their blood level is over 14, their antibody title also decrease. Yeah, also decrease. This is different vaccine. Yeah, 1, 2, 3, 4, 5, 6, 4. 7 different vaccine. We can see in the gray group, there are antibody titles, antibody title and antibody levels also lower than the reference group. Yeah, this is the reference groups. This is the gray group. From the finger, we can see clearly. Yeah, the red side, the red line is the gray group. Yeah, their antibody in the blood is decreased. But in the reference group, their antibody level is increased with the age. Yeah, increase with the age. So this suggestion should conduct and need to get more vaccine. This result will show this kind of body. So the reference group is lower than the exposure group lower than the reference group. Yeah, this also is a school student. He is from UAE, so he in research and he joined our lab. He this research now he is a student in UT UCF in America. You can see also the blood white cells, the children's blood cell is higher. This means have the inflammation by the chemical. You can see different white cell. Different white cell is here, include the nuclear cell. The nuclear cell is higher, a little higher. The gray group, the red one, is gray group higher than the reference groups. Yeah, means gray children have a little inflammation in their human body. And this is the predator. Predator is also one kind of blood cell. Yeah, the smallest blood cell. You can see also the predator also a little higher than the reference group. The predator cell also the white cell is if increased. Yeah, means inflammation. And you can see the nature cell, the nature killer cell. Yeah, nature killer cell. Nature killer cell is one kind of lymphocyte. Yeah, lymphocyte. They can direct kill the tumor cells. Cell will stick in the exposure group and is close, then lower than the group. We also measure the hemoglobin, different hemoglobin. This result is very interesting that the gray group have the higher hemoglobin than the reference group, than the reference group. Yeah. The mechanism is not clear now. We also want to try to find the answer. Yeah, why the hemoglobin in gray group is higher, but the antibody level is lower in the exposure group. This is the nature killer cells in the exposure group is lower than the reference group means this means their natural view function is yeah, intermediate most show diagram most lipophilic show in the exposure group is lower. Yeah, this interleukin is also the natural immune function, have the natural immune function. Yeah, just I say the blood, the platelets. Yeah, is the smallest blood blood cells. Yeah, they also participate in both innate nature and adaptive immune response. Can be used as a good additive of lower grade inflammation in children. Yeah, so we can see there is the grade group. Yeah, a little higher. And here if we measure the blood cells, we can find that. So social yeah, information in our body. See the the intercranial and is high. The great level of this is the level of systematic inflammation and the vascular endothelial were higher is in green, indicating co-exposure of gluten increased risk long cardiovascular disease through inflammation. Other health risks also has the inflammation. We find many evidence that they have inflammation after the exposure. So conclusion, we can find in the yeast recycle children is the blood level and the other pollutants is higher than the reference group, and many inflammatory cells hormone. Predator cell and B cell hemoglobin is increased, and also some internuclear is also increased. But the nature killer cells and the antibodies is decreased. Yeah, decreased. So our this talk focus on the antibodies. Yeah, is decreased. This is a reviews we just published. In this reviews, we have point out some possible mechanism of protein exposures, reduce antibody levels after vaccination. Yeah, there are different ways. Yeah, through several different ways. Yeah, for detail, you can find this review to have a look. Yeah, the WHO have a working on the exposure children organisms working and to certain engineering and then the Indonesia, the third India, the work group meetings photo. We have published genuine on place children house in first working meeting. We can materials Also some training material, training PPT in WHO website. This is the review papers read by this working group, published in EHP and other journals. So these reviews provide scientific and technological support for the formulation of corresponding international conventions, standards, development plans, major research plans, and forward-looking policy suggestions. Okay, yeah, that's all. That's all. Thank you for your joining. Thank you. My term is finished.
Thank you very much, Professor Dr. Shahu, for sharing your very important results regarding e-waste and heavy metals pollution impacts to the vaccinated and to the lymphocyte and petalite cells. If someone has some question, then he or she can unmute his microphone and can ask the question from Professor Shahu.
Hello, Professor Shahu.
Hello.
I would want to find out if we use the vaccines for a very long time, will that not have adverse effects on humanity?
Okay, sorry.
Can you repeat your question again slowly, or just you can also drop a chat question on the chat, then Professor Shahu can answer your question.
Okay, let me quickly drop it on the chat, please.
Thank you very much. I welcome the president of Society of Environmental Geochemistry and Health, Professor Michael, just has joined us, and I welcome the Professor Michael. Professor Michael, can you listen me?
Yeah. Hello.
I'm fine. Thank you very much.
Thank you for organising this meeting.
You're welcome. I am very grateful, and all the Asia members are very grateful to you for providing the kind opportunity to arrange a workshop regarding e-waste pollution and public health.
Yeah, hopefully you find this valuable, and maybe we will see many more of them.
Sure. In future, we will arrange many more.
So it's very easy to set these up, isn't it? This kind of format. So we've done these successfully from Europe across Africa and worldwide, and it's kept the interest going during the pandemic, which has been a very difficult time for everyone.
Yeah, sure, it is. And surely we will arrange some more meetings in this format in upcoming days.
Well, hopefully many of your audience will be very keen to see this format and put forward some ideas for presentations.
Yes. Thank you.
It's nice to see such a good audience of almost 40 people.
Thank you very much.
Thank you for organising it. I'll let you get on.
Okay, Professor Michael. Have a nice time.
Yeah, thank you.
Professor Shahu, will you answer the question asked by Mabezdi, Dr. Mabezdi?
Beg your pardon. Can he repeat again his question, because I cannot hear very fluently.
No, he has dropped a question on the chat. And the question is, will prolonged use of vaccines not have adverse effects on humanity?
The vaccine validate.
Yes. Yes.
Get you.
Will prolonged use of vaccine? You can.
He gives the question at the talking board. Sha, you can check in the checkboard. 他把这个他把问题留在了这个聊天板上，你看一下。
Okay.
The well prolonged use of a vaccine not
have adverse effect on human. Where prolonged use of vaccine not have adverse effect on
difficult questions to answer.
Where prolonged use. In children, they are in different age have different vaccines. In China, together have two different kinds of vaccines are free. Against the different virus and bacteria. Not only one kind of vaccine. Together, there are two different ones. So the adverse effects compared to the effects by the virus and the bacteria is very, very, very little. The virus and the bacteria can cause serious diseases if without vaccine. So I don't think the vaccine have serious and adverse effects. Maybe have someone have a little, but not compared to the adverse effect by the virus and the bacteria. This adverse effects is nothing.
Thank you very much, Professor Shahu, for your valuable information regarding the e-waste pollution impact to the children's health. So our next speaker is, our next talk is cocktail of hazardous substances in the informal e-waste recycling sectors of Indian cities, atmospheric emission and health impacts. This talk will be delivered by Professor Dr. Paromita Chakraborty. I will introduce Professor Dr. Paromita Chakraborty. Professor Paromita is an associate professor at Department of Chemical Engineering in SRM Institute of Science and Technology, India. Dr. Chakraborty leads the environmental science and technology research group, and her group is intensively working on freight, transport, and cost-effective remediation technologies for legacy and emerging contaminants. Professor Chakraborty has published over 75 scientific articles, 12 book chapters. She is an associate editor for Arabian Journal of Geosciences and in the editorial board member in the Science of the Total Environment. I welcome Professor Dr. Chakraborty to deliver his talk.
Thank you, Professor Zafar, and thank you for organizing this important meeting. And of course, it's a big opportunity to give some of the bites of what we are doing in terms of informal e-waste recycling in India. I guess my slides are visible. Yes. I'm audible, right? I'm fine.
Yes.
Yes. Okay. Yeah. So as like Professor, it's interesting to see that we already had a good interaction with Professor Ho, It was in Indonesia. And it's this really important topic and a very important arena wherein we need to discuss this e-waste story, especially in the Asian countries and also in African nations. So I will be talking about mostly on the informal sectors, what's happening in India. So the outline of my talk would be a little bit brief about what we are seeing, the global status, and what we are seeing in India, and what kind of sampling we have done, what sort of experimental setup we had, and the research highlights and the ongoing research that we are doing in the group. So as we all are aware of that any electronic gadget with the end of life cycle, it ends up in the waste stream. And the major chunk of the electronic waste, it includes metal and plastic. Now, metal is the one that is lucrative one, but many a times the plastics or the casings, they are ending up in the waste stream, many a times not being recycled or reused. In the global scenario, if you see like the major chunk was coming, the Asian countries, the e-waste was entering in Asia. Apart from the fact that we were getting the waste from developed world, we were also generating the quantity of electronic waste at the domestic front. So the main recycling areas are situated mostly in India, China, and other developing countries in Asia. And now I think the scenario is getting important in Pakistan, Bangladesh, in South Asia. And then, of course, Ghana was also found to be one of the important sources. So where recycling was taking place in the informal sector. So it's important why this electronic waste are actually ending up in the informal sector. One is it is a very easy business, the mining of the precious metals. And with the precious metals, as my previous eminent speakers mentioned, like different kind of toxicants can be released. Now, more than 90% of this electronic waste are actually taken up by the informal sector. This is also because it's easy to access in this developing economies. The labor cost is easy and there's a huge job potential. And definitely this metals, mining metals are a lucrative business opportunity also. So where in the mine, what we are seeing in the developing world during the same time, like time frame in the atmospheric emission of different toxicants, especially when it comes to, we have seen a lot of stories with polychlorinated biphenyls. And in China, like if you see, this is like 2000, early mid 2000, the data that was coming out. And all the stories were highlighting the fact that informal e-waste recycling in developing economies could be an important source for this kind of persistent organic pollutants. So it is important, like then in 2011, like bringing in all the data put together, we had an important question to ask, like, are this reduction in industrial organic contaminants emission in rich countries? It is because these are exported to the developing nations, wherein like we saw a lot of decrease in the developed nations, like this paper in Skuster et al., like they have seen an atmospheric decrease in PCBs, wherein like in Europe or in North America, these levels were decreasing, and the developing economies, the countries like China, India, or in Ghana or an African coast, the levels were increasing. So with this, what we were trying to understand is like with our previous work that we have done, and we could find the evidence that informal e-waste recycling is an important sector. Apart from the fact that definitely open burning is also one eminent factor in developing economies, where some quanta of electronic waste might be ending in the solid waste stream. And this organic contaminants, which are highly semi-volatile in nature, so this tropical regions might be an important area where this might be emitting in the atmosphere, which is why again atmosphere becomes very, very important. And then it's not just one set of compound, but we may get a multiple pool of such compounds. And these compounds can have weird and very severe health impacts It can be carcinogenic, and especially most of these compounds are endocrine disruptors, which means they can mimic the hormones and bring in a hell lot of health diseases, apart from several other mutagenic or teratogenic factors. So this compounds has gained a lot of attention, and we need to think about those and in terms of where they are getting into. So now coming into the Indian scenario, what we have seen is like initially we saw that PCB levels were pretty much high in the West Coast, where we have seen that we are housing the highest shipbreaking activity in the country, which is again also because of the low cost labor facilities, and which is also little bit needs sustainability issues are there. And this was something similar what Iota et al. Found in 1994, like about a decade and a half back, that the PCB levels higher in the west coast of India. So being the one of the shipbreaking facilities, like the world's actually highest volume shipbreaking is taking place in Alang and Soshia, the west coast. But then we found something interesting, like we found atmospheric levels were actually statistically correlating with the amount of electronic waste generated by major Indian cities. But again, this could be just a coincidence. So, but we had some hints. The profilings were a little different, and then we tried to enter like what could be the newer sources. And we tried to model using the existing emission inventory. And the interesting part we see, you see here for PCB 28 modeling, like what within the inventory, what we could using FlexPert, we could quantitate the amount of PCBs that might be emitted given the meteorological conditions during that time frame. But the actual concentration, what we got experimentally, were pretty much higher, almost 100-fold higher in most of the cases, both in the day and night concentration. So this gave us a hint that yes, the inventory was not including this informal e-waste recycling as one of the factor, which we were slowly seeing, or even open burning was not part of the inventory. So then e-waste recycling, it was hitting our mind, like, can there be newer sources which are actually coming in, which could be responsible for these levels. So then we entered to the story, like what is the status of electronic waste in India? Now, if we see, like, this is an old Basel Convention report, of course, January 2018, China has banned taking all the electronic waste. And then again, the load would come to definitely more onto, already India, Pakistan were taking in, but we might be taking in even more. And the main cities in India that are generating this electronic waste are Mumbai, Delhi, Kolkata, Bangalore, and Chennai. And these are located in northern, eastern, western, and southern part of India. So these cities becomes very important, and also they are generally they are generating good quanta of electronic waste. As like, for example, Bangalore. These are all metro cities, high, and they are having high IT hubs as well. So what we are seeing, like this is what we were seeing while we were visiting those sites, like the good quantity.
Hello. Hello, Dr. Paramita.
Certainly locked,
Something,
right?
yes.
Yeah, something wrong.
Maybe some internet problem, internet connectivity problem.
Yeah.
We can wait 1 or 2 minutes for Dr.
So
Paramita. Maybe.
can hear?
No,
Oh,
no, I
she
cannot
said can hear. Can't
Let me
hear.
Yes, she can't hear. She is not here.
So
Maybe some internet
yeah,
problem.
maybe he go outside and come in again. Yeah.
Maybe. We can wait. We can wait for 1 or 2 minutes. I just asked from her on WhatsApp. I have her WhatsApp number. Yes, she said that she will join 1 or 2 minutes. We can wait for 1 or 2 minutes.
So cannot hear.
Yes.
So you have her WeChat.
Yes, I have her.
Yeah.
Yes, she is now online.
Coming.
Sorry, extremely sorry. There was a network
Welcome.
issue. Yeah.
Welcome.
Yeah, thank you. So coming back to the questions that we wanted to answer with this e-waste related issue in India, that we were looking into the fact that most of the electronic gadget has a good quantity of the plastic component in it. And in most of the sectors, what exactly they do, like different kinds of plastics that are there, that might contain a good quantity of, say flame retardants, and also when they are extracting the metals from those plastic component, so some burning activity is taking place. So with this materials, are we going to see a lot of contaminants that might be coming out? So not only in the recycling sector, but also we can see when it is dumped and openly dumped, and burning activities, which is again very common. So we try to understand whether it is emitting a hell lot of contaminants, which might be very, very dangerous, and especially when they're coming in as a cocktail. So the problem statement we had, like there was a huge data gap. We didn't have any story coming before that from India. So what we tried to understand is, with this informal recycling sector, what are different kinds of compounds that might be coming in? And if there is a possibility, some of these compounds are also going for long range atmospheric transport or any other transmission mode. And looking into the multimedia movement of these compounds and how it might affect the biota. So what first thing we did a survey of the entire informal e-waste sector in different Indian cities. And we found that they are actually doing in stages. It is not happening in the informal sector in one particular place. So somewhere the dismantling is going on, where they're segregating the material, and then they will be doing some kind of incomplete combustion process to take away. Once the casings and other things which are segregated, which are easy to recycle, then comes the printed circuit boards from which metal has to be recovered, or the cable wires from which metal has to be recovered, because that is the main business. We need to understand that. And sometimes in the nearby dump sites, the sludges are being dumped. Otherwise also, already Professor Tanabe and his group has established the fact before we started with this, that open burning in Asian countries is a major source for many of this persistent organic pollutants. So it is important to look into the dump sites parallelly, whether this kind of materials are ending there as sludges, waste sludges, or some unused products ending up in the solid waste stream. So different segments, different stages will give rise to different layer of toxicants that might come. This was what we saw with the survey, and we were hypothesizing based on the survey. So what we did, we have collected from all the major Indian cities, we have collected passive air samples, dust samples, soil samples, and we have also looked into the fact that in Chennai city, we could access like one of the main city area, which one of my scholars, he just got his degree yesterday. He completed his PhD yesterday. So he was working on this, and we could deploy the high volume sampler even in the amidst the city where the recycling was taking place in Chennai. So passive air sampler, which is again very cost effective and very easily used and has been used globally. It's a very good monitoring device for developing economies. So that can give a quick time integrated concentrations. So the passive polyurethane foam disc passive air samplers were used. And in addition to that, like see, we had to start with dioxin furan as well, but we had limited fund. So what we did is like we collaborated with Yoshi Corporation Japan, and we tried to evolve a method where we used the chemically activated luciferase expression calyx assay, and we screened down the samples for the instrumental analysis. So this is again also was very important. And the regular schedule of analysis that has been gone, and we have used ECD, DCMS, HRGC for different set of compounds. And with this, we also tried to do whatever samples we had. This was another important work by another scholar who has also received his doctoral degree last year. And this, what we try to see is that whether these compounds that we are getting when we are exposed linked to the microbes isolated from this contaminated sites, how much these compounds could be bioavailable to those microbial species. So what did we see? First interesting thing what we saw was like initially we took the pool of the data set and was trying to correlate whether with the calyx assay and the real-time data were similar or not. But interestingly, when we pull the data together, we were actually less correlation. But when we distributed the data based on the site types that we saw during our survey, the correlation was so good, so significant. So we understood that this is a source-oriented factor is there, like based on the kind of process that is taking place in the informal EVS sector, the kind of compounds might be emitting differently. Say, for example, in the informal metal recovery sectors, we were seeing more of the dioxin-like compounds. So that was one important observation that we saw in those initial source-specific calibration factor could fit in better for those sites. So when we looked into the soil, if you see that we saw very high concentrations of PCBs and dioxin-like PCBs made up more than 80% in those informal e-waste recycling sites. And not only this, we were also seeing a lot of, we parallelly did a lot of metals. That's why I meant cocktail of toxicants. We were seeing in those sites, lead, copper was high, and we were also seeing plasticizers, because then again we were expecting that because they are removing those plastic gadgets and getting the metals from those gadgets, so it is obvious that we might get a lot of quantity of plasticizers in that incomplete combustion processes. So what with PCBs we did something, what we did is like we tried to run a positive matrix factorization modeling, and we saw what importantly I would mention here, that PCB 126 made an important factor even for those all the informal e-waste recycling sites. Of course, open burning has been found as one of the important source for PCB 126. But then again, what we did is we tried to see what is there in the technical formulations for all this dioxin-like PCBs, because we were seeing more than 80% dioxin-like PCBs in the e-waste sector. So what interesting part I would mention here is, if you see in the technical formulation, PCB 126 is actually in trace level, or in some cases not present. And we were seeing for all the e-waste sectors, like informal sector in different stages, there was prominent concentrations of PCB 126. So that was an important point that that came to our notice. Okay, this could be associated with now informal e-waste recycling. And what then we started seeing, like whether there is for the hotspot sites, the soil is getting saturated and there is emission of this heavier congeners in the atmosphere, which is why possibly in the next results we are seeing higher concentration in the atmosphere. Not only PCBs, if we look into the PVDs also, the hotspot areas, when we look into the hotspot areas where informal e-waste recycling was taking place and compared to a very less active zone, the concentration levels were 20 folds higher in those active sites. So coming back to the fact that we have deployed a high volume sampler, so let's first understand what we saw with this high volume sampling. You see a strong difference between the source area, the concentration difference between the source area and the suburban site where such informal e-waste recycling was not happening. So this was one indication, and also when we ran the clusters, most of these were the localized clusters that were taking the air masses that was generating in and along these sites that could have been the major cause for this high concentration, what we expected. Looking into the passive samplers, where we divided the sectors not only in the e-waste, but also we found out like that IT corridor, nearby IT corridors, they were also an influential factor. And open burning dump sites or industrial sites were still lesser in terms of the kind of contribution that it was giving to all these metropolitan cities. We tried to also track back. These are the only those dates, black carbon, where we were seeing very high concentrations for all these sites. It was also tracing back that the concentrations for those during those time spent for these cities, the those sites, especially closer to the electronic waste belt, like the black carbon levels were also high in the source points. Now, what we understood by these cities, which we considered one terms, is that there was coastal cities, there were also inland cities. An interesting important point that we could identify is that the inland cities, say for example, like in New Delhi, which is our capital city, there the air mass, the residence time of the air mass is much higher compared to the coastal cities like Chennai and Mumbai. And even in Bangalore, which is also an inland city, but not as inland as New Delhi, but still the air mass residence time was higher, and in Delhi it was more, which is why possibly in the inland regions and especially in the subtropical regions, the impact might be even stronger with this kind of high concentration of this different kinds of pollutants that are being released. And what now, like if you look into the picture, like in the sources that we could see, if we divided all the different site types, then informal electronic waste recycling sector was actually contributing the major percentage of different toxicants, as I mentioned in the title, as a cocktail of toxicants, which is like next highest level could be from the industrial sites or the IT corridor. But this informal e-waste recycling sites were actually contributing the major chunk. And with this, like again, we saw for the dioxin-like PCBs, even in the atmosphere in those sectors were much dominant, even in the PMF models. And again, we could check that again, the story which lied in the soil, also in the air, that PCB 126 from those sector was really reasonably high. So definitely, like our levels were of course lesser than TISO, but we have to constantly check it and monitor it in the longer term. And but it is higher than some of the reports from Africa and Bangladesh. And in some cases, we were actually exceeding the WHO tolerable limit for this informal e-waste recycling sector. And not only this, we are also working on the pristine regions. We are seeing that there is possibility of long range or even short range atmospheric transport of some of this persistent organic pollutants, and which could be coming from with the trajectory modeling. We are understanding they could be from this source regions. Coming to the health impacts, as giving a summary that we are seeing more of the more toxic components in the metal recovery sites, followed by the open dump sites. So we try to have the nearby dump sites and the e-waste sites as a comparison to see whether what was established, that open burning is still a source, but metal recovery sites are again prominent sources. not only in terms of PCBs, but of course the carcinogenic pHs were also high in the cities, and we could see that the metal concentrations were also high, which was leading to higher metal exposure in those metal recovery sites. Especially it was maximum for New Delhi. Another interesting part where in the dust we could see the finer dust particles where the less than 2.5 micron, there we see the more loading of the toxic metals, which means the workers, we have to now work out, like the workers or the children who are there around surrounding that belt, because these are workshops which are mainly controlled by low income groups. That could be, they could have more health exposure. So these are the research questions we need to answer in the near future. And looking, again, I told, like when we took the microbes and contaminated soil or sediment, and we have tried to expose those concentration, and we have seen that the bioavailability for those microbes, where the concentrations, especially for PCBs, were higher, we could see that the bioavailability factor was also high. So this is again another way, a good part, that possibly these microbes can be used for remediation of such contaminated sites. So now what we are seeing is definitely this passive air sampler is a good factor to understand the atmospheric concentration for this pool of compounds. And during this pandemic time, we are also checking like whether open burning, which is still prevalent, are giving rise to different kind of molecules. We are seeing that PBD levels, if you see here, 2007, what we observed, and now it has increased by 3 to 4 folds, which is, again, we are considering the most important factors could be this informal e-waste recycling, and definitely open burning might be, again, another significant factor. So in future, what we are trying to answer more research questions, we are looking into not only just the abiotic component, but we are trying to look into the fact how it can have, it can impact human health. This is our long-term plan for next 5-year plans that we are working out. And another important and very important sector is this, how the different plastics, ending up in the waste stream can release variety of POPs. This is what we are looking at. And so I need to acknowledge all the funding agencies: Ministry of Environment, Forest and Climate Change, Government of India, Department of Science and Technology, Government of India, and our ongoing research on this plastic incorporated toxicants. It's a dialogue between the Prime Minister of India and Norway. So we have this Inopol project with 5 partners, SRM being one, taking care of the POPs part. And of course, loads of, I don't know what to say more, but I have got an excellent research group, very positive and very promising young guys to work with, young engineers, young researchers, and a very good team and good postdocs, and also visiting fellows and some stalwarts visiting us, like Professor Logan, and also Thorian visiting us from NIVA. So it's an amazing journey we are going through. And this is a short brief that I could explain in this short time, and with the break, I really apologize for that. It was not in our control. And thank you for your kind attention.
Thank you very much, Professor Dr. Paramita. One of our participants just commented that Professor Dr. Paramita has a huge work, and you have given a brief overview regarding the status of e-waste pollution from India in different environmental compartments, and then you have focused on some monitoring studies regarding e-waste status in the air, their health impact, using in vivo and in vitro models, then something about your research group and the funding. Is there any question from the participants? So unmute your microphone and you can ask the question from Professor Dr. Paramita. Is there any question?
I must say thank you, Alikos. Thank you, Thambin Percy, for your positive comments I can see in the chat box. And yes, it was quite a huge work, and entire team, yeah, we worked as one. And thank you. And we hope to do more work. And if there is scope for collaboration, please feel free to communicate. Yes.
So thank you very much. Now this is my turn, and just wait a minute. I am sharing my presentation with you people. Thank you very much, Professor Dr. Paramita. Can you see my presentation?
Yeah, yeah.
Thank you very much.
Yeah, clear.
So I would like to introduce myself. My name is Dr. Mohammad Zafar Hashmi. I did my PhD from Chichang University, China in 2015. Currently, I am working as assistant professor at Department of Chemistry, ComSat, University Islamabad. My research mostly focused on the environmental monitoring of pollution. I developed some novel methods to monitor the environmental pollution, the toxicity mechanisms of the chemicals, and to develop the treatment technologies for e-waste pollution and arsenic. I am associate editor with the Arabian Journal of Geosciences and editorial team members with the Chemosphere. I am book series editor with Springer entitled Emerging Contaminants and Associated Treatment Technologies, and also the book series editor with the Elsewhere Advances in Environmental Pollution Research. From the previous audience, from the previous speakers, such as Professor Tai Chang and Dr. Paromita Chakraborty, has given a brief overview regarding the status, the monitoring status, the pollution level of electronic waste pollution. So as you know that the electronic waste are electrical materials we use in our everyday life. These material uh, come into their end of life, they are useless, and sometimes we recycle them, sometimes we burn them, and sometimes we dump in the environmental compartments. Due to these activities, these chemicals produce some toxic chemicals such as polychlorinated biphenyls, PBDs, some other heavy metals. So when these chemicals enter into the environment, different environmental compartments, but we don't know that which level of these chemicals is safe for the public health. So my research, my today talk will focus on these aspects of the electronic waste pollutants, that which level of these chemical is useful or could be considered as threshold level for the public health for the environmental risk assessment. The title is Polychlorinated Biphenyls Congeners Induce Toxicity in Human Lung Cells. And these are the contents of my talk. And you know that the central pillar in toxicology is that of dose response relationship to determine risk assessment and regulation. For this, there are two threshold models exist. One is threshold model, and another one is the non-linear threshold model. You can see here that these both models are not reliable, some false, and the blunder. Nowadays, the research is focused on the biphasic dose response model. It means that at lower concentration of the chemicals, the response of any endpoint is maximum at the lower concentration of the chemicals, and the response of any endpoint decreases as the dose of the chemical increases. This model is considered as accurate, robust, and highly generalized model. So there are some characteristics of this toxicology model or biophysic dose response model that is highly generalizable, independent of biological model, independent of endpoint, independent of inducing agent. It model provides the accurate information, and it has been used for different biological endpoints. But there's a lack of studies regarding the mechanistic foundation of the biophysic dose response model to generate the threshold levels for different chemicals. As you know that PCBs have this like structure. They have 209 different types. They are hydrophobic, bioaccumulative, recalcitrant, toxic, and they pose some toxic effects to the public health, such as tumor production, dermal toxicity, hepatotoxicity, immunotoxicity, carcinogenic, reproductive toxicity, and neurotoxic effects. These are produced through different e-waste recycling and burning activities. They are persistent and they could be migrated to the grass upper level, and they could be volatile, and they could also be transported into the food chains, and ultimately they can pose some toxic effects to the human beings. The question is that how the PCBs induce or trigger some response. What are the mechanisms behind PCBs induced toxicity? There are different school of thoughts, and there are different research that have figured out the mechanism for the PCBs induced toxicity. The first one is the cell signaling mediated mechanisms, and these have been reported for different cells, and these could be considered as a potential mechanism for PCBs induced toxicity. The another mechanism may be receptor mediated mechanism, some overcompensation. These are less accepted model and mechanism for PCBs induced toxicities using the in vitro models. It has been reported that PCBs induce toxicity in the cells in vivo and in vitro models by triggering by activating the reactive oxygen species that could lead towards the activation of the mitogen activated protein pathway and the apoptosis or cell death pathway that is known as C-gen and terminal kinase pathways. As you know that if the e-waste pollutants are present in the environment in the environmental compartments, then the human lungs can get or receive these chemicals through different ways, through inhalation from the atmospheres, and through blood from the food chain. So the question is that after once they are inhaled, then PCBs can have some effects to the human lung cells that they can cause some lung cancer. So what are the potential mechanisms through which the PCBs pose some toxic effects to the human lung cells? So this was the main idea of the research which my group is studying to figure out this type of question. So these were the research objectives, and this was the technical roadmap for the study that you can see here that I choose 4 chlorinated PCBs and 5 chlorinated PCBs, then figure out the effects on cell proliferation, apoptosis, membrane integrity, cell cycle mechanisms. Then for this, I studied the cyclin E, CDK2, P21 caspases proteins. Then 5 chlorinated PCBs, there are some cell cycling mechanism for cell proliferation and apoptosis proteins. This was a generalized cell culture model, and these were the structure of different PCBs. They may be non-coplanar and coplanar PCBs. This was the media condition for the growth of the HeLF cell, human lung fibroblast cells in the laboratory. So this was the experimental design, and the results suggested that the low chlorinated PCBs, PCB40 at lower concentration uh, uh, induce stimulatory responses in the HeLa cell, HeLF cells, human lung fibroblast cells. And you can see that the level 10.5 and 10 raised to power 3 have maximum stimulatory responses, which is 110 to 109%. And these responses could be considered at threshold level for environmental risk assessment of the PCBs in the environment. However, at higher concentration, the PCBs 40 showed inhibitory responses in the HeLa cells, HeLF cells. Then similar trends were also found for the PCBs 77, and you can see here that 10 raised to power minus 1, the PCB 77 showed maximum stimulatory responses as compared to other doses and the higher doses of these chemicals. It suggests that this dose could be considered as a threshold level for risk assessment determination. Then I studied the effects of these 4 chlorinated PCBs on the cell membrane integrity. And you can see here that PCB40 increase the cell integrity, while the PCB77, it is a non-coplanar PCBs and it reduces the cell membrane integrity. Then I figure out the effects of PCBs on the cell cycles, and you can see here that with respect to different doses and over the times, the G phase of the cell cycle is increasing after exposure to PCBs 40 concentrations. Similar trends were also found for PCB 77, and you can see here that after 24 hours, the G1 phase of the cell cycle uh, increased. However, with the passage of the time, after 48 hours and 72 hours, the G phase decreases while the S phase increase. This suggests that both PCBs have different effects on the cell cycles in HeLF cells. Then I studied the effects of both PCBs on cell cycle protein expressions. And you can see here that the expression of cyclin E, cyclin D1, P21, caspases 9 decrease after exposure to non-coplanar PCBs 40, while the expression of CDK protein was unchanged as compared to the controls. Similar effects was also noted for PCB 77, and the Western blots results indicated that PCB 77 induced cyclin E, CDK, and P21, but the trends of these protein was increasing with the passage of time and with respect to the dose. So the conclusion is that non-coplanar and coplanar PCBs at non-cytotoxic concentration increase the cell proliferation, while at higher concentration decrease. Low concentration of PCBs alter membrane structure and increase the in-membrane fluidity, suggested that PCB40 followed the mitochondrial pathway to kill the HeLF cells. Flow cytometry revealed that PCB40 increased the percentage of G1 phase but decrease S phase at concentration and time-dependent manner. Western blot analysis also indicated that PCB40 and PCB77 increase the expression of CDK2 and P21 protein. Cytotoxicity mechanism of the PCB congener depend on polarity and chemical structures. There are some prospectus that caspases proteases and P53 should be considered in future. These are the proteins that cause the death of the HELF cells. Cell cycle, all the membranes of cyclines and CDK should be considered in future research. These are some prospectus of the research. Then I studied 5 chlorinated PCBs effects, toxicity effects to the HELF cells. For this, you can see here that this was a studies design, and I choose two type of 5 chlorinated PCBs. That one PCBs 101 and PCBs 118. You can see here that the effects of PCB 101 on cell proliferation, and at a lower concentration at 10 raised to power minus 3 and 10 raised to power minus 2, the cell proliferation was maximum after exposure to PCB1. It suggests that these levels could be considered as threshold levels for risk assessment for these PCBs, while the higher concentration reduce the cell proliferation of HELF cells. You can see here the similar effects of PCBs 11 were also noted, uh, and you can see here that at 10 raised to power minus 2 and 10 raised to power minus 1, the maximum stimulatory responses of PCBs were recorded. PCB 1118 were recorded. However, with the passage of time and with the increase of the doses, we can see the reduction in the cell proliferation of the HELF cells. Then oxidative stress was studied to figure out the mechanism behind the cell proliferation. You can see here that for both PCBs 101 and 118, at lower concentration, the oxidative stress was unchanged. However, with the increase of the dose and over the time, the oxidative stress become maximum. Similarly, that antioxidant enzymes activity were also figured out, and you can see here that the MDA activities, this is antioxidant enzyme with response to neutralize the effects of oxidative stress. You can see here that its activity also increased for both PCBs with the passage of time and with the higher concentration of the PCBs for both PCBs. Then oxidative enzyme were studied, which was GSHPX proteins. And for both PCBs, the decreasing trends of oxidative stress was noted with respect to time, with respect to higher doses of the PCBs. Similarly, the another oxidative enzymes, you can see here that its concentration slowly increased, but with respect to the higher doses of the PCBs, you can find here that the response of this enzymes decreased. We also figure out the effects of PCBs, genotoxic effects of the e-waste pollutants in HELF cells. You can see that PCB 101, it is less toxic, and it induces less genotoxicity in the HELF cells as compared to the PCBs 118. You can see here a long tail of the DNA at a higher concentration of PCBs as compared to PCB 101, suggesting that PCBs can induce genotoxicity in the HELF cells. Then some protein mechanism, mitogen activated protein kinase pathway exposed to PCB 101 was studied. And you can see here that the different proteins expression was unchanged with respect to different doses over the different times after 4 hours and after the 48 hours. While the coplanar PCBs 118 have some effects on the mitogen activated protein kinase pathway, and the expression of different proteins was less with the passage of the times. So conclusion that is that the biphasic effects on cell proliferation was found in HeLF cells treated with non-coplanar PCBs, which reflect a beta-shaped dose response curve. Low concentration of PCB 101-118 induce enhanced RAS generation without cytotoxicity and a cellular protective effects. It was found that PCB 101 and 118 showed expression of ERK protein after 4 hours, while after 48 hours the protein expression was less, indicating PCB toxicity to MAP protein of HeLa cells. There are some prospectus that it is important to in future to study the transcriptomics or quantitative structure activity relationship analysis for these PCBs to different cells. So this is my research networking. I have research collaboration with Michigan State University with Professor Dr. Syed A. Hasham, Macquarie University, Australia, Professor Vladimir Strizev. He is my supervisor, Professor Dr. Shen Xiaofeng from Chichang University, Professor Dr. Xiaojin Thangs from Chichang University, and Professor Dr. Paramita Chakraborty from SRM Institute, India. So I am book series editor with Springer. This is the title of the book series: Emerging Contaminants and Associated Treatment Technologies. If someone of you is interested to publish book, so you can drop email to me. Thank you very much. If you have some question, then feel free to ask from me. Is there any question? No question. So thank you very much. So our last presenter, Dr. Ahad Nazarpour, is not available. He has some emergency. So this is the end of the today workshop, and I just want to how to quantify the amount of toxin. Dr. Wakar Ahmed asked a question, a very nice question from me, that how to quantify the amount of toxin PCBs that induce toxicity in the lungs. Mostly we use GCMS to quantify the PCBs for example, if we want to, we cannot directly sample the human lungs because it is very difficult to sample. However, we can we can quantify these chemicals in the blood samples. It is also possible in human blood samples, or we can also if we used in vivo or in vitro study. Just in my study, you can see I used human lung cells. These were cultured in the laboratory. So we can sample these human lung cells, and from these sampling, we can determine the quantity of PCBs. And our last presenter is not available. Just want to summarize that, as you know, that e-waste, which is known as electronic waste, are electronic products which we use in our daily life. No doubt they have some applications for us. They are very beneficial for us. But when the life of these products ends, then they are the significant cause of the environmental pollution, which you have saw in different presentation, such as Professor Tachan, Professor Dr. Paramita Chakraborty has highlighted the trends of these pollutants in the environmental. So these pollutants have some toxicity to the environment, to the public health. And I am very grateful to all the presenters who have given their valuable times and have shared their valuable experience regarding the e-waste pollution and environmental health. Thank you very much. I would like to invite the president of the society, Professor Dr. Michael Watts, to have some comments, to have some suggestion, to say something.
Okay,
Professor
thank
Michael.
you. I do actually have a question that I've put in the chat box. I don't know if
Yes.
this is a question that can be answered. It was just a thought as we went through these presentations. It's very exciting to see presentations that are measuring a biological response to an exposure event, whereas traditionally we've often seen studies presented at conferences that infer a potential health problem rather than measuring a health response to an exposure event. So I wonder, for biological systems, they often have a greater allowance for uncertainty of measurements than, say, chemistry. I wonder, just as I was listening to these talks, I wonder what would be an acceptable level of uncertainty on your measurements, because I often see some figures there that provide ranges of measurements. I wonder if you have any comment for that.
Thank you. Thank you very much for your very good question and technical question. Yes, there are some chances of uncertainty or reproducibility. I think if we used some larger quantities of the data, you can see that I used near about 90,000 10 raised to power 15 cells for one cell. So in this type of data, it could be a possibility that we can reproduce the uh, uh, the experiment. We can reproduce the measurement. It is also possible that there is some uncertainty in the results. Both things are possible in the results.
There's always going to be a measurement of uncertainty, isn't there? So it sounds like for biological systems, you simply overcome that by sheer numbers of measurements.
Yes, we can also, yes, we can use some replicates, such as in my case, I used for one treatment duplicates. So in this way, we can use reproducibility of the data.
Yeah, I thought Alikos Dimitriadis might have a comment about that, the measurement of uncertainty. It's certainly an issue that has been raised more recently, and certainly I handle papers for a few journals, and so commonly you see papers coming forward with lots of very nice interpretation, calculations of risk and all this kind of thing, nice GIS presentation, but no information about the confidence in the measurements, how the measurements were produced.
Yes.
And yeah, it's still quite a problem. And we've been running a writing workshop for African early career researchers in the last sort of 6 months or so. And it was quite interesting. We were trying to introduce writing skills and how to write papers. So we had a couple of editor-in-chiefs providing lectures, but we also provided an introduction around measurement of uncertainty, thinking it would be a fairly boring subject. And actually it generated the most discussion. It was the most heated discussion amongst early career researchers from across, there's about 50 or so African early career researchers, but we had many other people joining us from around the world. So I think it's something that perhaps the SEGH community could contribute to, is raising awareness and the type of controls that researchers and early career researchers should be thinking about when publishing their work and getting it accepted internationally. I don't know if you have any thoughts about that.
Sorry, I cannot get your question.
I think the SEGH community could be very helpful, particularly to the early career researcher community, in providing information and understanding for the measurement of uncertainty. Particularly when they come to publish their results, so that they are more acceptable in journals.
Yes, I think so. That I totally agree with you that it is a possibility of uncertainty in the biological system when we use some biological endpoints to measure some such type of research, to do such type of research. Of course, if there are some activities in future, the young researcher can join. We can do some workshop on this issue.
Okay. We do actually have the recordings from this African researcher, early career researcher writing skills program on the SEGH website. So we have the recordings of the lectures and how to write papers from the editors-in-chief of two journals.
Thank you very much.
Can I just say something else for SEGH? Many thanks to all of the speakers for putting this these talks together. It's very interesting topics around e-waste, and like I say, actually presenting work that deals with a direct response to an exposure event rather than inferring a response, which is what many traditional studies have done in the past and what we often see in presentations. And thank you for putting this collection of talks together. This is very much appreciated. What would be quite nice is perhaps if presenters could produce some blogs, nice informal written text with a few photographs or diagrams for the website. If you have time, I know you're all very busy, but also the audience would be very welcome to do that and communicate their work or highlight a paper that they've just produced on the website and try and engage as a community. This is a very nice start to re-engaging SEGH Asia, which has been very quiet for the last 2 years. This SEGH online platform has been very successful over the last year or so in engaging members and new people from across the world, in particular focusing on perhaps some of the early career researchers who have provided events in America, Europe, and in particular, a lot of energy from Africa. So maybe there's another event for early career researchers perhaps, and it's a very safe platform for people to practice their presentation skills online. It's a safe audience that should not be too challenging. So I'd like to encourage that and greater diversity from the Asia Pacific region. So that's perhaps thinking about future meetings and future energy and making use of this community to interact and share ideas and share your work. And that may well spark some new initiatives and project ideas to work together. So many thanks to yourself, Mohammed, for putting this meeting together. And I do hope to welcome more of you as members to SEGH and get involved in the organisation of the SEGH community and future events. I would like to note that we are currently asking for nominations to replace me as president. I'm coming to the end of my second term, and it's time to hand to somebody new with new ideas and fresh perspective, and ideally from another region would be nice, because we are truly a global community. We've gone in the last 2 or 3 years from about 17 to 38 countries, so that's a big move forward. And we have about just under half of the members as early career researchers, so lots of young, fresh and exciting people involved. So if you would like to nominate yourself as the next president, please do email some text which might suggest why you would like to be president. You can email me directly, or you can, so mwatts@bgs.ac.uk, or you can email via the website to the SEGH webmaster. Okay, and well, thanks very much again for hosting this meeting, Mohammed. Over to you.
Welcome. Thank you very much for your kind appreciation, and I'm very grateful for providing the kind opportunity all the time.
May I say something?
Yes.
Okay, acting on Michael's sort of comment, I have put up the measurement uncertainty guide. The EuroChem is the 2019, and I definitely agree with Michael that this is needed in all your work because you are doing work which is very sensitive
Yes.
to, let's say, the environment and also health. And measurement uncertainty definitely must be there. Otherwise, you know, your results will be not taken very seriously. It is needed for publications as well.
Yes. Thank you. Thank you very much for your very kind suggestion and costs.
Can I just follow up on the comment? It's not just for publications. This is important to have confidence in measurements for any research, but also thinking about how that research is going to be used. So it may be that important decisions are going to be made on that data. It could be a commercial decision around, you know, a mining operation or cleaning up a site, but also we're dealing with public health here. So there may be decisions made or people are informed that make policy decisions based on data. So that data needs to have the confidence. Yes. I think it's a very important thing. And this kind of uncertainty in measurements has been around for a long time, and I'm sure it will always be a problem, particularly as new methods of measurement arise and technology improves. So it's still, you know, something that probably people assume has been solved over the years, but I think it's a continued problem that needs to be refreshed and everyone reminded of that the data could have a very real impact on people's lives. So it's important to make sure we have confidence in it. And that provides confidence in the scientific community from the general public, who of course will be the taxpayers who probably provide much of the research funding. Yeah. Okay, thank you.
Thank you. Thank you very much. I totally agree with you.
Now a comment on Michael's comments. I definitely agree with all comments made by Michael. And there is also another aspect that Michael Ramsey could have told us more. There is a legal aspect as well, because all these data are very, very sensitive. And sometimes you may be in front of a court. Okay, so all your data must be validated. In fact, this is very, very important. Okay, you don't know how your data is going to be used anyway. Okay, so it's important for you generating the data to have all these things built into your data. You know, so measurement uncertainty is a must.
Thank you. Thank you very much.
Yeah,
sure,
we should just reiterate, this is not a criticism of today. This is a general issue worldwide and all the time, yeah. So, yeah, some very nice presentations. Thank you.
Thank you. Thank you very much. Thank you. Okay, I think this is the end of the workshop. And thank you very much for the speakers and for the participants. Have a nice day. Bye bye.
Thank you. Bye bye.
Bye bye.
Thank you. Thank you.